order derivative of the x, and equation 1 is said to be the normal form when it is written as, अगर हम equation number 1 को ये implicit form है और this is the explicit form, अगर हम इस equation को इस form में convert कर लें तो then it is said to be the normal form of this equation 1. अगर तो हम यहाँ इसको हम explicit form में लिख सकें, like ये तो mixed है ना, यानी कि nth डेरिवेटिव, फर्स्ट डेरिवेटिव, सेकंड डेरिवेटिव, ठीक है, इंडिपेंडेंट वेरिएबल, ये मिक्स है. अगर हम इसमें से xn जो x की पावर n यानी कि nth डेरिवेटिव है उसको हम एक्सप्लिट कर सकें तो फिर हम इसको क्या कहेंगे, नॉर्मल फॉर्म ऑफ द इक्वेशन 1. And here f is this small f is a function of the n plus 1 variable. Here these are n plus 1 terms, so f is function of the n plus 1 variable. And it is very important to say that not every equation 1 like जरूरी नहीं जो equation 1 है वो always can be converted to the normal form, ऐसा possible नहीं है. बाज़ औक़ात ये certain conditions है satisfy करेगा, then it can be converted to the normal form of the equation 1. So we consider the first order ordinary differential equation in the normal form. हम जो further जो consider करने जा रहे हैं, जो जिसको discuss करेंगे वो first order ordinary differential equation. And the initial condition x of t0 is equal to x of 0. The problem consisting of the system 2 and 3 is called initial value problem. So the definition is this is the first system is the ordinary differential equation of the first order, and thus this condition is called initial value problem. This is the initial time. T0 is the initial time, and the value of x at T0 is equal to x0. X is the function from the interval to the given set. Like here, if we are going to discuss about domain is like we can take here the domain of the f is, for example, the domain of f can be defined from I cross or n Rn, defined from interval the solution defined from x from I to Rn. So the function x is from I to Rn, and if in the vector value function like x, the equation 2 can converted to the first order differential equation, the system of the first order differential equation. इसको हम further यानी कि कोई भी second order differential equation है, third order differential equation है, fourth है, fifth है, तो इन सब को हम first order differential equation, system of first order differential equation में construct कर सकते हैं. Like जो और उसका जो expression होगा वो हम जैसे कि ये x prime है, तो x prime के लिए हम इस तरह डिनोट कर देंगे x1 prime vector value function में, x2 prime यानी कि let me erase this thing. Okay, the system like here I can write like in this way, x1 prime, x2 prime, so on, xn prime is equal to, if in the matrix form I can write this system here ये x को जो हम डोनेट कर रहे हैं वो x1 prime, x2 prime, xn prime. If I am going to discuss about f from domain, जो इसके domain है वो I cross Rn है, Rn है तो इट्स मीन this should be in this form. ठीक है, तो इसको हम और every nth order differential equation second fourth something can be converted to the first order differential equation, the system of the first differential equation. वो हम न्यू वेरिएबल इंट्रोड्यूस करके तो हम उसको कन्वर्ट कर सकते हैं इजी. So we are going to discuss about the first order differential equation. अगर फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन को सिस्टम को डिस्कस करते हैं तो इसमें के इसमें जो nth ऑर्डर है सेकंड है वो सारे इसमें कवर हो जाएंगे. Let me erase this one. And the condition is x is 0 is equal to x of 0. This problem consisting of this system is called initial value problem. To study the existence and uniqueness and the further property problems or the initial value problems, we consider initial value problems in the form this, and where as I told you f is equal to f1 f2 fn, like the domain from d f, the function f is defined from d to rn. Okay, and the domain is an open set of r cross rn. Choose any interval or can take r, it depends on the function. So this is the r the variable t from here and the variable x from rn, variable t from r and the variable x from rn, and t0 x0 is the initial condition, so it must belong to the d, that is the domain of the function. Your domain say belong to it. Next we have the definition of the solution. A function phi of t is said to be solution of the initial value problem if phi of t is differentiable in an interval j containing to uh, such that t phi of t belongs to t and phi prime is identical the right hand side. If we put the phi in the given differential equation, first order differential equation, the initial value problem, then it is satisfied. So this is the definition of the uh, initial value problem. And here I can say that a function by graphically I can explain it in the next pages. I can the graphical representation of the solution of the initial value problem in the next page. So this picture is consider the initial value problem x prime is equal to tx. Here we have x prime is equal to tx and x at 0 is equal to x of 0. ये पिक्चर थोड़ा सा क्लियर नहीं, मुझे याद नहीं रहा कि इसको दोबारा देखा, ये थोड़ा सा क्लियर नहीं. x of 0 is equal to x0, x0. तो ये मैं दोबारा पिक्चर सेंड कर दूंगा ग्रुप में इस अकेले पेज पे. By solving this problem, we see that x is equal to x0 e की power t square over x. T square over x is a solution of the given initial value problem which exists on R. अभी हम ये initial value problems कुछ solve करते हैं और check करते हैं उनकी existence के बारे में, उनके solution के बारे में. By solving this problem, we see that x is equal to x t square x is a solution of the given initial value problem. ये इस initial value problem का जो solution है x is equal to x0 e की power t square over x, and you can solve by yourself. It can be solved by the separation of variable, so you can solve by yourself. So this is the solution of the initial value problem which exists on R. अब ये exponential function है, तो x0 e की power t square over x. This is the exponential function and which the solution exists on R and is unique. This solution is unique and exists on the whole real line. Next, we have the example number 2. Consider the initial value problem first order differential equation. This is the initial condition x at 0 is equal to x0. We see that x is equal to x0 over 1 minus t x0. You can solve by yourself and you can check. This is the solution of the given example number 2, like this initial value problem. Is the solution of the given initial value problem and is unique for x0 is not equal to 0. The solution exists on minus infinite, 1 over x0. इसकी जो डोमेन है, जो solution की डोमेन है वो डिफरेंट. इट्स मीन हियर द एग्जांपल नंबर 1 और 2 में क्या डिफरेंस है कि वहां पर भी सॉल्यूशन एग्जिस्ट कर रहा था लेकिन उसकी जो डोमेन है वो 4 रियल लाइन थी. बट हियर द डोमेन इज नॉट 4 रियल लाइन. It can be divided into two parts. Like if x0 is not equal to 0, the solution exists on. अब ये डिपेंड करता है ये इस इनिशियल कंडीशन पर. जो डोमेन है वो किसके ऊपर डिपेंड कर रही है? इनिशियल कंडीशन के ऊपर कि आपके पास x at 0 is equal to x0. तो अगर तो यहाँ से हम इसको t की वैल्यू जो है, अगर t की वैल्यू 1 ओवर x0 पुट करते हैं तो सॉल्यूशन डिफाइन नहीं रहता. ठीक है ना, सॉल्यूशन इस पे एग्जिस्ट नहीं करता एट पॉइंट 1 ओवर x0. सो आई रोट ये ओपन इंटरवल एंड 1 ओवर इफ आई रिप्लेस. अब डिपेंड करता है कि x0 जो है वो नेगेटिव है या पॉजिटिव. ठीक है, अगर तो पॉजिटिव है तो इसका जो सॉल्यूशन है वो डिफरेंट होगा, उसकी जो डोमेन है वो डिफरेंट होगी. अगर x0 नेगेटिव है तो फिर उसकी डोमेन भी डिफरेंट होगी और सॉल्यूशन का जो ग्राफ है वो आपको मैं यहाँ से शो कर सकता हूँ. आई कैन ड्रा द ग्राफ हियर लाइक लेट मी हियर I can write the graph. So x is equal to x0 over 1 minus t. Like here, the first I can draw the graph of here minus infinity to 1 over x0. When x0 is greater than 0. If x0 is greater than 0, it means that this is t here, this is t, and this is x. And at t0 is, let's say it is positive, x0 is positive, so it is here x0, and the graph can be drawn in such a way that 1 over, yes, x0 1 over x0, like, oh sorry, let me, I can draw the graph. Draw the graph like this. This is the graph. 1 over x0, vertical asymptote. This is x0. So the solution exists on minus infinity to 1 over x0. So if the x0 is less than 0, I mean it should be here like this here, then the graph would be like in this one. So this is the vertical asymptote and this is minus 1 over x0. ठीक है, ये इसका वर्टिकल एसिम्पटोट होगा. इसका मतलब ये है कि सॉल्यूशन एग्जिस्ट तो कर रहा है भी यूनिक, लेकिन इसकी जो डोमेन है वो डिफरेंट. डोमेन डिपेंड कर रही है इनिशियल कंडीशन. सो डोमेन मस्ट डिपेंड ऑन द इनिशियल कंडीशन और फंक्शन दोनों के ऊपर डिपेंड करती है डोमेन. तो सॉल्यूशन यूनिक है लेकिन इसकी जो डोमेन है वो सेट ऑफ रियल लाइन है. होल रियल लाइन some subset of the real numbers. Next, example number 3. Consider the initial value problem. X prime is equal to absolute square root of the absolute value power 1 over 2. X0 is equal to 0. So this is again a non-linear first order differential equation. And let me check the chat. I think